Hi everybody. I am just going to go through a quick little video about what we were going to do during tutoring after school tomorrow. So follow along. I'm going to go first to our Unit 5 page in Canvas, and then we will go to, we have this page right here. So this sampling distributions review blank is what you want to click on first, and then that will take you to what I'm going to go through. It has something for you to first start off with. I don't want this picture there. I'm going to keep Xing out of that. First, start off with something that you can look through all of your notes to use to fill in. So we have sampling distributions for sample proportions, one sample, two samples. Then we have means, one sample, two sample, and everything on the left you should be able to find in your notes. So I'm going to have you pause the video while you download this document. You could print it or just copy it on a sheet of paper and try to go through all of your notes and organize the different sampling distributions that we've learned so far. While you do that, I'm going to share my screen. You can pause this and come back to it to see a filled in version. All right, what you should see now on your screen is that's still the blank version. And then what I'm going to show you here is the filled in version that I did earlier. So let's see, I'm going to hide this. And forgot how to do all this Zoom stuff. Let's see. Okay, so what you should be able to do is pause the screen and now check over your work that you had done with your notes and make sure that you have all of this in there. And then I'm going to zoom in and go through each little piece. So to start, the parameters are what come from the population. And so for one sample, if it's a proportion problem, and then let's add a little note about proportions. Proportions are, remember, binary. They're going to be yes or no questions from which we would call categorical data. The problem should say something about the word proportion a lot of times, so that way you'll know it's a proportion, or they'll give you a percentage. So we have our parameters, one population or one sample or two. And remember, with two, we're always doing the difference when there's two because we're comparing groups. Our statistics is what comes from the sample. So that could be p hat from one sample or p hat 1 minus p hat 2 if we're comparing two different samples. The mean and standard deviation are provided on your formula sheet. Don't forget, every time you calculate standard deviation, you check that 10% condition for however many samples there happen to be. And then for the normal condition on proportion problem, the rule is n times p and n times 1 minus p should both be at least 10. If you have two samples, you'll check that for both groups. Finally, we have the z-score formula, which is the number of standard deviations above or below the mean. We've been using the calculator a lot to calculate to calculate probabilities and haven't really been using the z-score. But questions love to ask for just the z-score filled in, or for how many standard deviations of value is from the mean. And so you will be able to use the z-score formula to calculate that. Now these formulas end up looking a little bit intense, especially if they go all the way across and look at the mean ones too. And so just remember that z-scores are value minus mean over standard deviation, just like we learned in Unit 1. The value is what comes from your sample, the mean is what comes from your population, and the standard deviation will be whichever formula it goes with that type of problem. So we'll go over to the means now. Here, means are going to be quantitative. You're looking for things that have amounts, and usually they have units to go with them, so be careful about that. And same kind of rules, we just use new symbols now. We have mu for population mean, mu1 minus mu2 for difference in population means. The statistics is what comes from the sample, so that's x bar. So just a little reminder, population, sample, We have our mean and standard deviation that we get on the formula sheet, and then whenever you calculate standard deviation, if you're doing something without replacement, we check that 10% condition. So remember, I'm just going to add that note, without replacement is the general rule for that, because of sampling without replacement. And then this one has new normal rules, remember. Either you'll be told that the population is approximately normal or normal, or if you're not told that, you should have at least 30 in your sample, which is called the central limit theorem. You're allowed to use CLT as the abbreviation for it, which I've been saying is very helpful since we live in CLT, so it's easy to remember. And then, like I talked about a minute ago, we have our 2 z-score formulas. So what I'm going to do now are a couple of practice problems. We have 1 FRQ from a 2010 AP exam, and then 3 multiple choice questions from some personal progress checks. So this whole sheet you could work on your own and then check the answers here, or you can follow along with me as I work through the problem. So we're going to start with this first one. We have a local radio station plays 40 rock and roll. We have the distribution of lengths of rock and roll songs in minutes is roughly symmetric with mean length 3.9 minutes. That'd be mu. And then our standard deviation is 1.1 minutes. Describe the sampling distribution of the sample mean song lengths for the random samples of 40 rock and rolls. So a sampling distribution should be, any distribution should include a description of the center, or let's start with shape, then the center, and the variability. If you don't include all of that, then it's not a complete description of the distribution. So for the shape, our goal for all of these is to be approximately normal. So we're going to go ahead and write that and then see why. We're going to look first for the population to be approximately normal, which they just said symmetric. So not normal necessarily. Next thing we would need is our sample size to be at least 30, which it is 40. So we're going to say 40 is at least 30, and that is the central limit theorem in action. By the way, this is a parentheses and then CLT. I'll fix it and make it look better. Now, for the center, since this is a mean problem, let's just highlight the word mean, and that's how I would know that this is going to be a mean problem. Also notice like the minutes, those are the units I was talking about, and so I would go to my mean section. These are proportions here, and then these are the 2. There's only 1 sample of 40 songs, and so these are the formulas I'm going to be using for the means. My computer's a little bit slower than I am, so I'll wait for it to show you what I'm talking about. There we go. All right. So mu of x bar equals mu, sigma of x bar equals sigma over square root n. And then we want to also check that 10% condition. So let's go ahead and write everything down. Mu of x bar equals mu. And we already wrote down mu was 3.9 minutes. And sigma of x bar equals sigma over square root n. So that was 1.1 over the square root of 40. And then let's see what that is. Wait, 1739 minutes. We're also going to check that 10%, where we're going to say 40 is less than 10% of all rock and roll songs. Feel okay about that? We'll check that off. Okay, the program manager schedules 80 minutes of news and advertisements for the 4-hour show. Only 160 minutes are available for music. This is probably the total amount of time needed to play 40 exceeds the available airtime. So here's the thing. We have a total amount right here. This is 160, but everything up here is about the mean amount. So we need to turn that total into a mean. I'm going to just do a quick little thing here. Let's see, probability that the mean time, if I have a total of 160 and I'm going to play 40 songs, that means I can have 4 minutes per song on average. So I'm going to say X bar exceeds, that means it's more than 4. So we have our normal distribution. We have our mean of 3.9, standard deviation of 0.1739. We're going to draw the curve. We're going to label 3.9 in there, and then we're going to the numworks. Let's see if I can get that pulled up. There we go. Distributions. Normal, 3.9, 0.1739. Next, and then we want to exceed, so we're going to do greater than 4, and we get 0.2826. Remember, let the calculator show you how you want to draw that. Let me look back one more time. Okay, so we're going to put it right about there. Shade to the right, and I already forgot the answer, 0.2826. So that shaded region represents a 0.2826 chance. All right, so take a look at that problem. You can pause, look back over it. Remember, anytime a question says distribution, we need shape. Let's see, I'll do blue. Shape, center, variability. Okay. So this next thing, we're just going to go do 3 multiple choice questions. We picked these from the personal progress checks. And so we picked one from each that we liked. And so I would just follow along here. You can pull it up in your personal progress check if you want to practice any others. All right. So we have R represents a sampling distribution of an estimator for samples of size 35, and S, same idea, but samples of size 15. So they're using the same estimator. So what that means is both should have the same expected value. The expected values are going to be the same if they're estimating the same unbiased estimator of the same parameter. But then, remember we learned as sample size goes up, variability would go down. And so R should have less variability than S. So A. So the smaller sample will have more variability. The bigger sample will have less variability. Since R was 35 and S was 15, then the variability bar will be less than S. Okay, next one. We're going to do B, number 2. Our squares got a little messed up here, but that's okay. You can still see it. So this says, what are the mean and standard deviation of the sampling distribution of the proportion? So this is where you want to be able to go to your formula sheet and find proportion, one sample, mean, and standard deviation right here. And so we're looking for the mean and standard deviation filled in on this problem. Looks like we're going to need mu of p hat equals p, and sigma of p hat equals square root p 1 minus p over n. I would just copy those straight down from my formula sheet on a problem like this, so that way I can look through the choices and pick the best one. So P would be the percent they give us in the problem. So we're looking at this proportion of attendees from the Northeast. And so they say 30% of the attendees are from the Northeast. That makes P equal to 0.3, which really eliminates all the choices but C. And so we'll just make sure our standard deviation is correct. 0.3, that 0.7 is 1 minus 0.3, and our sample size is 25. 25 will be selected. So you should be able to do a problem like that on your test when you'll see formulas filled in and you just choose the correctly filled in one. We have a little extra question here. How would you determine the shape? So remember, shape is right here, approximately normal when. So I'm going to write that down on my paper and then just fill it in to get the answer. Okay, so I like to just write the rule down, approximately normal when n times p is at least 10 and n times 1 minus p is at least 10. We know n, 25, p, 0.3, and that would be 7.5, and then that is not at least 10. So we would just say something like not approximately normal. Notice that's not what the question asked, so we added that just to get to practice doing n times p and n times 1 minus p. If anything is not true, then we would say it's not approximately normal. And we don't have to worry about the other type of shape right now. Okay, last one, Unit 5, Personal Progress Check C, number 10. So here we have a lot of information. I like to just kind of sometimes skip all the words and read the last sentence just to see if I can answer it without getting bogged down with everything else. So this is, which of the following is the best reason why the sampling distribution can be modeled by a normal distribution? So here we're looking at x bar 1 minus x bar 2. So I'm going to go up here. X bar 1 minus x bar 2 is this one, 2 samples for a mean. And so we're going to check these rules for both of the groups now. So either the population should be normal or our sample sizes should be at least 30. Let's see what's going on here. So I do want to scan now the top. They say the distribution is approximately normal. And then we have another distribution that's also approximately normal. And then our sample sizes are only 10. So it's going to be about the populations being approximately normal. It's not A, not B, because they're only 10. C, populations were normal. We don't have a rule for that. And that's only for standard deviation. So this answer was C. And then bonus question, what's the mean and standard deviation? We'll get these from our sheet. So I like to just fill out the formulas and then use them to answer the question. So we just wanted to practice this in case this comes up somewhere else on your test. So mu1 we'll say is 53 minutes. I'll just do an equal sign. Let me highlight these. Okay, so we have mean 53, standard deviation 2.5. And the other one is mean 56, standard deviation 5.1. And then we have samples of size 10 and 10. So those are everything we need. 53, let's see, X bar 1 is town council meetings. And then X bar 2 was arts council. So we got 53 minus 56 equals -3 minutes. Keep it negative, that's okay. And then this one we'll do 2.5 squared over 10 plus 5.1 squared over 10. And then I'm just going to quickly get that answer. 1.796 minutes. And then remember that we're going to do 10 is less than 10% of all town, town council meetings. We have to assume that's true. And 10 is less than 10% of all arts council meetings. All right. Now the last thing I want to mention is that this negative mean, that's okay. Remember, it just means that arts council meetings are an average of 3 minutes longer than the town meeting, since we did town minus art. So you don't have to write that down. I just like to know why the distribution is negative, because the town was less than the arts. So, all right. Well, this little worksheet was just something Mr. Crouch and I made up to do in our review session after school tomorrow. Since that's not happening, we thought we would just film a video of it so that you could still experience that, just like we're in a review session. So hopefully you did it on your own and then checked your work with me. If not, you hopefully paused and tried a couple of things. And feel free to email us if you have any questions throughout the day. And we'll be here on Thursday morning to answer any more questions, or also Wednesday morning. All right. Thank you guys so much for your attention. I look forward to seeing you soon.